Another example of finding inverse function, and then we're going to verify that they are in fact inverse functions. So I'm given here f of x equals x cubed plus 1. I'm going to find the inverse function. So substitute in y equals x cubed plus 1. Swap the x's and y's and solve for y. So subtract 1 from both sides equals y cubed. And now I'm going to take the cube root of both sides. So cube root of x minus 1 equals y. So that is now the inverse function. Now, an interesting thing, if they are inverse functions, if I take f of the inverse function of x, I should get x as my result. All right, so I'm going to work myself over here. So that's what I'm looking for. So I know that the inverse function is now the cube root of x minus 1. So if I take f of the inverse of x, I know that that is, since f is x cubed plus 1, I know that that's x cubed plus 1. I put the inverse function in for x. All right, so I'm going to put the cube root of x minus 1 in there, and then solve. Well, the cube root of something cubed is something, and x minus 1 plus 1 equals x, and it worked. And I should actually be able to go the other way. I should be able to do the inverse of f of x and get x again. Now let's see if that works. So let's start off with the inverse, which is the cube root of x minus 1. I'm going to put f of x in here, which is x cubed plus 1. And then I'm going to solve. So I've got the cube root of x cubed plus 1 minus 1, which is x cubed. And I know that the cube root of x cubed is x, so it worked. So f of the inverse of x is the same as the inverse of f of x, which when you solve it, you get x. And that is how you verify inverse functions.